So let's look at another example, still looking to find our the six trig function values, but this time I'm given that the terminal side of theta is defined by the line x plus 2y is equal to 0, and I know I'm only interested in the portion of that line for x greater than or equal to 0. In other words, I'm only looking for the positive x values. So if I'm looking for the line, let's start by thinking about graphing this line. Now remember that if I have the line, this is a line, x plus 2y, and the easiest way to graph that is to put it in its slope-intercept form. So x plus 2y is equal to 0. I'm going to solve that equation for y by subtracting x to the right-hand side. So 2y is equal to negative x. Divide both sides by 2, and I find out y is equal to negative 1/2 x. Now the reason that I wrote it as negative 1/2 x and not x over 2 is because I'm interested in, if I'm going to graph this equation, I'm interested in the slope, because remember, in slope-intercept form, that's the easiest way to be able to graph a line. So if I come over here now, drawing my graph, we know that this is the slope because because b is understood to be 0 here. If we're talking about the slope-intercept form of an equation, then we know that we're going to start my line at the origin, right? So that's where we cross the x-axis at. That's the y-intercept, is at 0. I also know that my slope says that it's going to be a negative line, so it's going to be dropping or falling from the left to the right. And so I'm going to move 1 in the y direction and 2 in the x direction. So this right here, this point right here, is where I would draw my line. Now, I know that I'm only interested in the positive x values, so I'm only interested in the portion of this line which is over here in quadrant 4. So I'm pretty good by drawing just that piece of the puzzle that I have drawn right there. Now if I were to finish this off by drawing my right triangle, I know that I have one leg, my y value is going to be a distance of 1, because I can see that from the graph, and my x value is a distance of 2, because again, I can see that from the graph. So if I come over here and I know that x is equal to 2, y is equal to negative 1, I didn't write that, but that's what it should be, shouldn't it? Because I went down 1 on my graph. And now I'm looking to figure out what r is. R is the square root of x squared plus y squared, or in other words, it's the square root of 2 squared plus negative 1 squared. So 2 squared is 4 plus 1 would be the square root of 5. So now, if I'm looking at my 6 trig function values of theta, and remember that theta, I'll draw this in a different color, theta rotated all the way around and ended up here in the 4th quadrant. So the sine of theta is defined as y over r, or negative 1 over the square root of 5. Now, I'm going to write it like that to start with because it helps when I do the reciprocal function values, but we can't leave the answer like this. We have to rationalize the denominator. Remember that when I rationalize the denominator, what I'm technically doing is I'm going to multiply top and bottom by the radical that's in the denominator. So I'm going to multiply top and bottom by the square root of 5. And when I do that, I end up with just the square root of 5 in the numerator, and the denominator, because I multiply the square root of 5 times the square root of 5, that gives me the square root of 25, but the square root of 25 is 5, so that eliminates that radical in the denominator. So negative 1 over the square root of 5, when I rationalize it, turns into negative square roots of 5 over 5. Okay, now let's move on. The cosine of theta is defined as x over r, so that would be 2 over the square root of 5 Again, we can't leave it like that. Let's rationalize, multiply top and bottom by the square root of 5, and I get 2 square roots of 5 over 5. Tangent is defined as y over x, so that would be negative 1/2. Moving on, let's look at cosecant theta. Cosecant of theta is the reciprocal of sine. So maybe now you can see why I left, or I wrote, instead of just thinking it in my head, I went ahead and I wrote down what sine was before I rationalized it, because cosecant is the reciprocal of sine. So it's pretty easy for me to look back here and say, oh, well, cosecant has to be negative square roots of 5 if I were to flip the sign function. Now let's look at secant and do a similar process here, right? So secant is the reciprocal of cosine. Cosine is 2 over the square root of 5, so secant must be the square root of 5 over 2. Now let's talk about cotangent. Cotangent has to be the reciprocal of tangent, so negative 2. So these are the 6 function values for a line that, this is the 6 function values for angle theta that's located on the terminal side of our line. One thing I do want to point out to you, notice that the tangent of theta, which is negative 1/2, it's not a coincidence that it is also the slope of my line. Something to think about as we move on eventually into calculus.